Okay, yeah, concerning the assignments, this is going to be a fast and a quick one. So I just want us to pay attention very well. So I just want you to explain the assignments and explain some aspect of differentiation. So for this first question now, you have your question now to be y equals to cos minus 1 over a. Now I wrote some things here. This is just shortcuts that you may need in your exam. So you may need this in your exam. Not, but you need to just know the basics first before you start using shortcuts. First, the shortcuts will not going to cut you. So now this is the question. Now the question now says dy dx of this. Differentiate this. So the first thing you need to know is that this is a trig function, and what you need to do first of all is to rearrange this. So rearranging this now, you'll be having you'll be having. Okay, now before solving, this is a trig question. Now the first thing you need to do is that you make use of, to solve this now, you'll be making use of chain rule. You're making use of what we call chain rule. This is another approach in solving differentiation. It's another approach in solving differentiation. So you make use of chain rule. Now from here now, you then, which is y equals to cos inverse of u, meaning that our x over a is our u. Do you get that now? So rearranging this, rearranging because of this inverse, so we can say our u equals to cos y. So you get, or we say still the same thing as saying cos y equals to u. So you get now, you just like say having, this is what it means, u y equals to u over cos. So when you cross multiply, you have it as this. Do you get that now? So this is, now having rearranged your question this way, now the chain rule, the rule now is dy dx equals to, we've introduced another variable, so that will be dy du times du dx. So this is the formula. So now what we need to first of all do is, what is our dy du? What is our dy du? So what's our dy du first? Now from u equals to cos y, so from here our du dy will now be minus sine y. She ignore now. From if you differentiate, so from the differentiation of the okay, du dy is now minus sine y. So you should know, when you differentiate sine y, you have cos y. When you differentiate cos y, you have minus sine y. Do you get that now? So we have this. Then what we're actually looking for is this. So from differentiation, I should know that will be the inverse. So that will be the inverse. Then we say dy du will now be, this one was du dy, so the inverse of this will now be 1 over minus sine y. Do you get that now? So we've gotten dy du. So the next thing to look for is du dx. How do we get du dx? So du dx is from our u equals to what? Cos y. If you look at it, cos y. So if you are differentiating du, okay, u is from our u is from this is our u, x over a, x over a. Our u is x over a. So our du dx, so this is with respect to x, this is with respect to y. U in respect to y, this u in respect to x. So you should understand that any variable you are differentiating with must be in that question. So you should understand that in differentiation. So to differentiate this, if you differentiate x, it becomes 1 over a. So you get now, this is a constant. So now to now get your final answer, dy dx for this question will now be dy du times du dx. So all you just need to do is bring it down, 1 over minus sine y times 1 over what? A. So from trig function rule, we have what we call 1 equals to sine square y plus cos square y. Should you understand? Sine square y equals to plus cos square y. It'll be 1 equals to sine square y plus cos square y. So if you are making this the subject of the formula, you are having sine square y to be 1 minus cos square y. Then removing this square, you know it's just sine y we're looking for. So sine y then becomes 1 minus cos square y all squared root. So you get, so this is our y. So apparently now we have y dy dx now to be 1 all over the root of 1 minus cos squared y times 1 over a. Do we get that now? So now to get the final answer now, to get the final answer, let's reiterate what we wrote now. Dy dx is 1 over square root of 1 minus cos squared y times 1 over a. Do you get that now? So from here now, don't forget cos y is u, or we say say the same thing as saying u equals to cos y. So definitely wherever we have cos y, we put in u. So we have 1 over 1 minus u squared. Cos square y squared is also the same thing as u squared times 1 over a. What is our u? Don't forget, recall, u is what? X over a. Do you remember that? So here we now have what? 1 minus x over a squared times 1 over a. Are we together? So then we have 1 all over, when you make this a subject of the formula, you have 1 minus x squared over a squared times 1 over a. Are we together now? So here then you have 1 all over, make this the subject of the formula, a squared 1 a squared. The LCM, sure you get LCM. The LCM of this will be a squared, then a squared divided by 1, a squared times 1, a squared, minus a squared divided by a squared, 1 times x squared, you have x squared. Are we getting it? Times 1 over a. Are we together? So going further, we have it to be the square root of a squared minus x squared all over square root of a squared times 1 over a. Apparently this can also come to the top, meaning that you'll be having square root of a squared all over square root of a squared minus x squared times 1 over a. So you get, from here we're having 1 over square root of a squared minus x squared over square root of s. So over, then you bring it up. By the time we linearize this, if you linearize this, you'll be having this. So you get, now you'll be having this. So then go further. Square root of a squared, what? A. Then the reason why you can't do the square root of this one and square root of this one separately is because it's having a sign in between, so you can't split it just the way we splitted this one. So you'll be having square root of a squared minus square root of x squared times 1 over a cancel a, so your dy dx for the first question is 1 all over square root of a squared minus x squared. So this is the answer. So if you just want to do it in a shortcut, this is just what you just need to do. Shortcut, you just come here, 1, this x is this. Do you get that now? This x is this. This is your u. I mean, this is your x. This x that is here, this is it. So just put it. By the time you look for the LCM, just that same way, everything will be squared. By the time you look for it, you'll be having a squared then x squared. So this is just a shortcut to solve this. Do you understand now? So that's just a shortcut to solve this. So this same way is also a shortcut to solve this question, but we are going to solve it using our hand as well. So the second one now, the second question, I won't waste much time on it. So y equals to tan inverse of x over a. So what you just need to understand here as well is that your u is x over a. So you're having y equals to tan inverse of u. Rearrange this, you have u equals to tan y. Do you get it now? So from chain rule, which is what, dy dx equals to dy du. You know, this u is the second variable we included, times du dx, so that this can cancel this, then we have this and this left. So that's just it. So from here now, our dy du is what? From du dy, how do we get du dy? That is from tan y, from this question here now. So you get it from u equals to tan y. So our du dy will now be tan y is what? Sec square y. That's tan y. So to differentiate tan y, you have sec square y. So let's go ahead. Okay, yes, we've gotten our du. So the next one is to get is our du dx. So our du dx now, from this aspect now, where's our, so here our u is x over a. Don't forget, our u is x over a. So our du dx, u in respect to x, will now be what? 1 over a. We've done that before. So merge everything together. Dy dx equals to this times this. So you have it as sec square y this is our du dy. So you change this, our du dy equals to sec square y. So you change it to what? Dy du. So it becomes 1 over sec square y. Do you get that now? So from our formula, dy dx equals to dy du. Hey, that was why I changed it. You have to reciprocate it, times du dx. So now from here we can now go forward to divide to multiply this. So dy du is what? Dy du is 1 over sec square y times 1 over a. So du dx is 1 over a from here. That's 1 over a. So from trig function rule, there's also what we know as 1 equals to one equals to sec square y plus minus tan square y. So to make this the subject of the formula, we just need to 1 equals to plus tan square y equals to sec square y. So make this the subject formula, we have sec square y to now be the square root of 1 plus. So 1 equals to sec square y minus tan square y. Then when you make this subject formula, it becomes this. So don't forget, what we are looking for is sec square y. So and our dy dx is 1 over sec square y times 1 over a, and sec square y is what? 1 plus tan square y times 1 over a. So and from the question u is tan y. If you look at it from this place, u is tan y, right? U is tan y from this place. So our dy dx is now 1 over 1 plus u squared times 1 over a. So we have it this way: 1 all over 1 plus x over a squared times 1 over a. So from here now you have it to be 1 over, find the LCM, x squared over a squared times 1 over a, just like the way we solved for this other one at this from this part here. So same thing goes or affects this one too. So we're having 1 over, by the time you find the LCM, a squared all over a squared plus x squared times 1 over a. So apparently this a can come up, so we have it. You understand why I said it can come up? If you linearize it, it comes up. So you have a squared all over a squared plus x squared times 1 over a. So if this a cancels a squared, you have 1a left. So you'll be having a all over a squared plus x squared. So the dy dx for this, as for the second question, the dy dx for the second question is a all over a squared plus x squared is equivalent to the shortcut, that is 1 all over 1 plus x squared. So whenever you're having x over a, this a is always coming to the top, then this your x is always remaining here, this a is always remaining here. So this part and this part is always carrying the denominator. So that's just relate it with this, so you get what I'm trying to say. So for the final answer and for the final question, which is y equals to log tan inverse of x. So this can be used in another format. We're having two things here. You're having two things here. You're having two things. Okay, yes. If we could represent this as y, I would say let y be log u, where our u is what? Tan inverse of x. So the rule to use to solve this now is also chain rule. Why are we using chain rule? Because we're having another variable, we are introducing another variable. Shall you get now? So our dy dx will now be dy du times du dx. So what's our dy du from from y equals to log u. So dy du, so you get y in respect to u will be what? 1 over u. So you get, so this is another thing you should as well know. When you have log x, the dy dx of log x is 1 over x. So you should understand that. So for this one will be 1 over u. So fine. So the next one is to know is the du over dx. So this one is from where u equals to tan inverse of x. From tan inverse of x, the dy dx, or let's say the du dx, meaning the u in respect to x, will now be what? Will be 1 all over 1 plus x squared. I gave you the shortcut that time. This is a shortcut. I gave it in this part here. So you see it here. So this is just it. This is the x. So this is it. So just a shortcut. So that's, so what we'll then do now is to what? We've gotten this, we've gotten for this, and we've gotten for this. So let's just multiply them together. So our dy dx is now what? Dy du times du dx. There we have dy du is what? 1 over u times du dx is what? 1 over 1 plus x squared. So our u is what? Tan inverse x. From here, so you see it, u is tan inverse x. So it's tan inverse x. So our dy dx fully will now be 1 over tan inverse x times 1 over 1 plus x squared. So merge this together, we have our final answer to be 1 over tan inverse of x 1 plus x squared. So this is the answer. 1, 2, and 3. So those are the answers. So don't forget to subscribe, like, share. I will also drop a link for all the shortcuts. It's on the page already, though I will put it in the description button so as you can check. Don't forget to subscribe, like, and share. Thank you.